So we need to determine if the given series is convergent or divergent. And we have the partial sum of n terms of this series, which is equal to 5 plus 8n squared over 2 minus 7n squared. If the series is convergent, we also need to determine the value of this series. So how we will solve this problem? First of all, we need to remember that if the sequence of partial sum, so if S of n is convergent sequence, then our series is also convergent. Too. Moreover, we need to remember that our given series is equal to the limit where n approaches infinity of S of n. Well, let's see how we can use it here to solve our problem. So first of all, let's write down the first few terms of our sequence S of n. So S of n is equal to 5 plus 8n squared over 2 minus 7n squared. So the first term would be 5 plus 8 over 2 minus 7. The second term would be 5 plus 8 times 2 squared over 2 minus 7 times 2 squared. The third term would be 5 plus 8 times 3 squared over 2 minus 7 times 3 squared. Well, let's calculate these terms. So our first term, 5 plus 8 over 2 minus 7, is equal to negative 2.6. Our second term is equal to negative 1.42. And our third term is equal to negative 1.26. We clearly can see that our sequence S of n is monotonically increasing because every next term is bigger than the previous one. And also we can see that this sequence is bounded above by 0. So S of n is less than 0 for all n. And from this we can make a conclusion that since S of n is convergent, so since S of n is convergent, then our initial series is also convergent. And now we need to find the limit of S of n. So the limit of S of n where n approaches infinity is equal to the limit of where n approaches infinity of 5 plus 8n squared over 2 minus 7n squared. We see that this is infinity over infinity form because 5 plus 8n squared approaches infinity, as well as 2 minus 7n squared approaches infinity. So we will apply L'Hopital's rule here. We will write down that limit S of n where n approaches infinity is equal to limit 16n over negative 14n where n approaches infinity, and this is equal to negative 8 over 7. That means that again our series is convergent and it converges to negative 8 over 7.